we kind of neglected to consider is this linear thermal expansion contribution and coefficient to strain. So what happens when we increase the temperature in our system to our material? So if I have a piece of aluminum, if I have a change in temperature where I increase, so the change in temperature equals T final minus T initial. If that is 100, what's going to happen? 100K, for example. Well, your material is going to tend to expand, and it's going to. Most materials will. So one exception will be lead titanate, which has a negative thermal expansion coefficient at certain kind of temperature ranges. But again, for almost every other material, as we increase temperature, the material is going to expand. So what's going to happen to our strain gauge as well? Well, that's also going to expand. So our material, our wire, is going to lengthen. So we are going to need to take this into account by looking at this linear thermal expansion coefficient, alpha L. So we can see in this definition here that alpha L, if we kind of rearrange this expression, so we can see that we have an expression here where dl is just basically delta L over L, and that's going to be equal to alpha times delta T. And that is going to be effectively our thermal strain. So we're going to have to tack this on, this contribution. We're going to have to add this to basically all of these kind of contributions here. So where we add E1, we always have to add plus E thermal, because whether on the top, bottom, wherever we are, the material is going to expand, and it's going to kind of measure that positive expansion in that direction. Now, when can this contribution be negative? Well, it can only be when alpha L is less than 0. So that is, again, a very rare case. Look at lead titanate BTiO3 and other negative thermal expansion coefficient materials. The other way this can be negative is if our delta T is negative. So if we decrease temperature, so for example. So be aware of that in these problems. Always kind of include it. That's kind of the most, kind of thorough condition. But lots of times, if temperature is not really changing dramatically, we can usually neglect this term. And in the problems, if you're not given kind of these values, obviously you're not expected to kind of remember or kind of know these thermal expansion coefficients intuitively. So next time we're going to get into the calibration of strain gauges, and yeah, I'll see you in the next video. Thanks. Bye.